This is all extremely cool stuff, really innovative technology, and the harder everyone pushes each other, the more successful we all are.
We are trying to develop and test tools to enable students to tackle complex autonomy tasks with drones.
Today we're at the Timpa Airfield in Tucson, Arizona. Here for NSF CPS VO Challenge, search and rescue. So basically the goal today is to autonomously detect and pick up an object and deliver it to another location. So that's what we're here for.
A program like this allows the students to address both hardware and software in a setting where the problem is challenging, and as we are trying this competition, starting with a pilot, we are developing the right tools to enable them. So it's together students learning how to address drone autonomy and also helping us to build better tools for them. Technically today is a calibration testing day. However, the weather is nice, potentially going to be windier on Thursdays, so we told teams that they can start scoring today.
Remove a third of, make it a third shorter from this end.
We're hoping to make a comeback from last year. Last year was a bit rough. We had just reworked all our tech stack into a new library and things of that nature, so we had a lot of bugs to work out. This year, library's been a lot more formalized. It's been around a lot longer, a lot more of the kinks have been worked out, so we're hoping to get up and running.
We're here on day one, coming in as defending champions from last year. Really hoping to kind of step up our game for this time around, learn from our mistakes we had from last year. And initially we just kind of wanted to come in, set everything up, just put some runs up on the board, get some things scored. And we were fairly confident, however, initially we had some software issues. We requested a score, walked back with a 0.
So the first thing we did was check all our equipment. Then we wanted to do a couple manual test flights, make sure everything functions as expected. We're also using a net as a pickup method. So we built a new net. Our one that we were testing with back home got pretty frayed before our trip. So we built that from the ground up, and we also had some new ideas on how to improve it.
Make it more like a dowel with a square. Make it more like a dowel.
Chances we have 3 spares.
Yeah, just let me know if you bounce, and we'll in the meantime try the one we have.
So initially today, we just wanted to kind of make sure everything worked. Big problem we were having back home is originally just getting all of the color accuracy of our cameras and sensors to work well. So the biggest problem is to make sure to dial in everything going from sunny, grassy, green Florida to dry desert of Arizona.
Change any variables, so you take it.
Yep.
Like, no variables to change at all.
Just call it and start.
Today we initially intended to go just do some test runs, make sure everything's working, but things seem to be going better than originally planned, so hey, I'll take it. Turns out just fixing a few things kind of caused everything to click together, and in the end, went back out, get some more runs, and we came back with a perfect 100, and walking away today as hopefully champions once again.
Y'all made that seem so easy.
Mission is done.
Yeah.
4 minutes 45 seconds. So it was a good start. So we have 4 teams. So Embry-Riddle already has scored and they're ahead. So 2 things will happen. One is other teams will probably get more trials because maybe Embry-Riddle won't go for more scored missions. However, they might still be trying experiments just to learn on their own. So they'll be a little more relaxed tomorrow and day after. So one thing I'm looking forward to is maybe something interesting with their platform, because now they can push it a little bit more and see if they can do things faster, and yet they may choose not to score.
I think one of the main challenges out here is the differences between simulation and the real world. So everything works in simulation, but when you come out to the real world, sometimes you tell your drone to do something and it doesn't do that thing. So the challenge is, how do you debug? In most applications, most of it is debugging and figuring out what your errors are rather than actual development.
2019 .00. Oh, we didn't turn it off, so it didn't set a new home.
So our goals for today were to nail down the search pattern. So we wanted to autonomously navigate using a series of waypoints that we were publishing for the drone to go to. And then after that, we tried to detect the image, land on it, and then pick it up using this winch system. So basically, there's a servo here and a pulley. We lower down this mechanism, and it would pick up a net of our object. Unfortunately, that didn't work.
80 points today is the goal, and then 100 tomorrow. The main goal of today of verifying the flight stack, we basically flew a portion of the competition earlier today. We didn't do a scored attempt, but we did essentially get the equivalent of the 80 points. Our battery died on the way back over there, and we didn't have time to get a new battery and get another test of that up and running, but we did verify that it was solely a battery issue.
I think this competition is very interesting in that, one, it's an application of just autonomy in any way, and I think there's very interesting aspects of that will be very beneficial in the future. If we can come up with safe ways to do reliable autonomy, then I think in the long run, it'll be better for all society.
So tomorrow, first of all, we have to start really early at 6 a.m. to get in some time. Hopefully teams will come prepared. They would probably be up late fixing things. And we want to start early, have some test flights, but more importantly, scored runs. Where did you connect?
This one.
No. Yeah, not USB.
That's the reason, right?
Why is till the PICSOC is on, we can't be doing anything? Yeah. What is this strap doing here?
We did a little bit of testing. We found out that our magnet is visible to our camera, and as the drone would come down to pick up our sample, it will, or our target, it will obscure sort of this QR code style thing. It's called an April tag.
Thinking, the double-sided 3M, but
oh yeah.
Then we have to put all these navigation lights that plug into the ESC.
I don't think we brought them.
Android has a ROS app.
Yeah.
So I'm thinking something that allows you to see ROS data on the phone, right?
So that the drone might actually lose track of what it's trying to pick up because it's getting in its own way as far as the vision. That's just a design component we'll take care of next time. We'll have the camera and the magnet a little bit further apart. And also another thing is we'll get more training on the machine learning side of things so that it has an easier time recognizing our target.
What I'm hearing here is that your TF, by the time the message is being read, it has an older timestamp. Is that what's going on? Because, okay, so TF, yeah.
By the time the vision code comes back with where it is in the world. So we went out, we did autonomous to search, then it found it autonomously, detected it. From there we switched to manual to pick it up, and then once we had snagged it, we switched back to autonomous. So it went over there, it did drop a bit early due to wind. We were flying fairly quickly, and then that combined with the wind overpowered the magnet. So we dropped the payload a bit early, but it still counted. And then we finished the run and then it automatically landed back at home.
The distance is huge.
The distance will be huge, but I'd give them a drop.
Okay.
It was close enough that it looked intentional. It wasn't like they dropped it right at the pickup.
We have the rod back.
All right. So you guys hit many checks this time.
Many.
So up to you. How much more you want to do?
Experience is pretty positive. I definitely had to learn and relearn a lot of things on the fly, and I think overall I'm much more motivated to, I kind of came into this not expecting much, but I think next year I'm going to be motivated to win. This competition here is enabling them to actually be out here in the elements, the sun, the wind, and see if they were to build field robotic systems to address commercial needs, the needs for the market, then what are all the challenges they'll face?
This competition, I think, is by far the best with that respect. I think the rules are phenomenal. I think it's really cool that you get 3 days to kind of test and tweak your solution as opposed to, like a single make or break test flight where anything could be happening. Maybe you get 40 miles an hour wind and the guy right after you gets nothing to deal with.
That was a little rough. And ideally next year I would want to come back with a better design, more improvements, better refinement, and I just want everything to be as best as it can possibly be.